Okay, hi guys. So in this lecture, we'll be doing some of the examples on the peptide linkage, which we discussed in the last lecture. Okay, so let's get started. So we'll have first question is how many dipeptides will be formed um, by two different amino acids. Okay, how many dipeptides would be formed or will be formed from two different amino acids. So obviously let's look at the example. So suppose we have glycine and alanine. So one of it can be N terminal on the left, C of the alanine on the right. Then we can have A and G. Then obviously we can have G and G and A and A. Okay, so the answer is 4. Okay, so next let us calculate how many tripeptides would be formed by two different amino acids. So next question is how many tripeptides will be formed from two different amino acids. Okay, so now the answer would be 2 raised to the power 3. The answer would be 8. Okay, so basically we have 3 boxes and we have two different amino acids. So here let's say first is A and another is, or let us say one is X and one is Y. So at this place we can either have X or Y. Similarly at this place we can again have X or Y. Again we can have X and Y at this place. So 2 possibility here, 2 possibility here, 2 possibility here, giving rise to 2 to the power 3, which is 8. Okay, so next the question is how many pentapeptides would be formed from 4 different amino acids. Okay, so how many pentapeptides will be formed from 4 different amino acids. Okay, so now we have 4 different amino acids and pentapeptides is 1, 2, 3, 4 and 5. Okay, so 5 peptides or 5 amino acids we have to link, and we have 4 different amino acids X, Y, Z and W. So at this place we can either have X, Y, Z, W, any of the 4. Similarly for all the 4 places, all the 5 places. So 4 multiplied by 4 times 4 is multiplied itself with 5 times, first, second, third, fourth and fifth. So answer would be 4 to the power 5. 4 to the power 5 would be the right answer. Okay, so next question is what is the structure of alanine at pH of 2 and pH of 12. So next is structure of alanine at pH 2 and pH 12. Okay, so obviously alanine would be something like this: CO2H here, NH2, H and CH3 here. Okay, so this is in normal conditions, this is a neutral. So when pH is 2, what will happen is NH3 plus would be formed, CO2H would be here, H and CH3 would be here. What when pH is 12, again CO2 minus will take place, NH2 would remain intact and H and NH3 CH3 would be formed as it is. Okay, so next let us take examples when we have something like this and plus H here and an H here, and so this is the compound we have. Okay, so the pK of this is 9, pK of this is 2, and pK we have been given in the question that these are the pKs. So what will happen when pH applied is 1, B pH applied is 3, then after pH is applied is 7, and then after pH applied is 10. So what will happen in this, in the series of application of different different mediums from acidic to basic? Okay, so first what will happen in the A is, when pH is 1, no change would be there. Why? Because the minimum pK is 2. Okay, so at pH equals to 1 we would have the same structure as above. Okay, and plus H here. Okay, what happens when pH applied is 3? So at 3, whatever the pK value of this was 2, hence this would convert itself into CO2 minus. So we'll have something like this. Rather, this was N attached here, beg your pardon, I drew it wrongly here. So N is here and plus H is here. Yeah, and then we have and CO2 minus here. Okay, then when the pH applied is what, 7? So at 7 what will happen is this will lose its positive charge. Okay, and we'll get something like CO2 minus and NH3 plus here. Okay, so next when pH applied is 10, what will happen is this NH3 plus will lose its H plus, and as a result final product would be this. CO2 minus here and NH2 here. Yeah, so this is the final product. Okay, so for an example, let's see what is the relationship between pH and pKa. Okay, so when pH is greater than pKa, it is medium applied, it would be basic. Okay, and when pH applied is less than pKa, it is acidic. Okay, so pH is nothing but pKa plus log of base upon acid. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing isoelectric point. Okay, so with this, good luck and goodbye.